In this video, I'm going to be describing how we can talk about congruent figures, specifically congruent triangles, and how we can name their corresponding parts, and finally name congruent triangles. So in congruent figures, corresponding parts have to be congruent. So in congruent triangles, corresponding parts are congruent. So a lot of times we'll use this reasoning, especially in proofs. So we can say the words corresponding parts of congruent triangles are congruent, or we can just use this acronym CP-CTC. Corresponding parts of congruent triangles are congruent. Corresponding parts are parts that are the same just on different shapes. So the same angle just on two different shapes, or the same segment length just on two different shapes. So if we can find parts that are corresponding and we're dealing with congruent figures, then those corresponding parts have to be congruent. Two figures are congruent if the following two things are true. Corresponding parts have to be congruent. So angles have to be congruent and sides have to be congruent. So make sure that the corresponding angles are equal and that the corresponding sides are also equal. Angles are what gives a figure its shape. So if I have congruent corresponding angles, I must have two of the same shape. Side lengths are what create a figure's size. So if I have corresponding side lengths that are congruent, I must have two shapes that are the exact same size. And if I have two shapes that are the same shape and the same size, they must be the same. So they must be congruent. So if we can figure out which pieces are corresponding and we're dealing with congruent shapes, they must be congruent. If I know I'm dealing with congruent shapes, then I must be able to find corresponding parts that are congruent. So it's the same forwards and backwards there. In some examples, you may be given the shapes and you may be given the congruency symbols. So to find corresponding pieces, we're just playing a matching game. So what corresponds with angle A? We're looking for an angle that has two arcs in this other triangle. So angle D and angle A must correspond, and they are congruent. What corresponds with angle B is the angle that has a single arc in this shape. So angle E must correspond with angle B, and they're congruent. What corresponds with angle C is the angle that has three arcs over here. So angle F corresponds, and those two angles must be congruent. We can talk about the segment lengths, and let's just be careful and match corresponding pieces and name them in the same order. So what corresponds with segment AB means that we're going from angle A to angle B. So what corresponds with that? Well, we got to start with what corresponds with A and move towards what corresponds with B. So D corresponds with angle A and E corresponds with angle B. So segment DE in that specific order is congruent to segment AB. What corresponds with segment BC? Well, what corresponds with B and C? E and F. So segment EF is the corresponding segment. And lastly, what corresponds with segment AC? Well, what corresponds with A and what corresponds with C over in this shape? Angle D and angle F. So segment DF must correspond with segment AC. And since we know that all the corresponding pieces are congruent, we can say that these triangles are congruent, and we just got to name them so that corresponding pieces are in the same order. So if I start by naming this triangle, triangle BAC, I need to name this triangle so that corresponding pieces are in the same order. So what corresponds with B is E, what corresponds with A is D, and what corresponds with C is F. So I have to name my triangle EDF so that corresponding pieces line up in the names. Sometimes you may be given examples where you're just given the congruency statement and a diagram without any of the congruent symbols, in which case you can use your knowledge of corresponding pieces to draw in the congruent symbols. So angle Q is going to correspond with angle R. So we could say that those angles are congruent and give them congruency symbols. Angle P is congruent to angle S. They already have a congruent symbol there. And angle T is going to be congruent to itself because it's a vertical angle here. And then we can name the segments. So segment QP is going to correspond with segment RS. So we could give QP and segment RS a segment congruency symbol. Segment PT is going to correspond with segment ST. So PT is right here, ST is right here. We could give them congruency symbols. And lastly, segment QT and segment RT correspond and are congruent. So QT could be congruent to RT by using the symbol. Since we have congruent segments, we must also have congruent distances. So if segment ST is congruent to segment PT, then the distance from S to T must be equal to the distance from P to T. So not only can we name congruent corresponding parts, but we can also start to talk about equal measures. Lastly, you might be given just the congruency statement without a figure to look at. So hopefully by this time, you can understand that we're just trying to match up corresponding parts that are in the same order in the name. So angle F corresponds with angle M, they're congruent. Angle G corresponds with angle P, they're congruent. And angle J corresponds with angle Q, they're also congruent. The congruent segments would be segment FG and MP, segment GJ and PQ, and segment FJ and MQ. So we can actually get all of the congruent parts just in the congruency statement here. If that's too much of a struggle, you can actually sketch out these two triangles. And you could describe the corresponding pieces by using your congruency symbols, and then you could go through and name all the congruent parts. Lastly, let's just make sure that we understand how to name congruent triangles. Is it accurate to name these two triangles as triangle JGF and say it's congruent to triangle MPQ? Well, no, we can't do that because corresponding pieces are not in the same order. So we can't say that angle J is congruent to angle M. They're not corresponding. They may not be congruent. And so we wouldn't want to name them that way. We would want to name corresponding pieces in the same order. So make sure that if you were to rename these, that you kept corresponding pieces in the same order. So now let's practice using this idea that corresponding pieces are congruent. And now we can solve for some measures here. So given these two triangles are congruent, then the corresponding pieces must also be congruent. So if the distance from T to U is 5, and that corresponds to XW, then the distance from X to W must also be 5. The measurement of angle V is 85 degrees, and angle V and angle Y correspond, they must be congruent. So angle V is congruent to angle Y. If V is 85 degrees, angle Y must also be 85 degrees. We can get a little fancier here with some algebraic expressions. If the distance from U to V is 6x minus 3 and the distance from W to Y is 3x plus 18, then we can actually solve for the distance from U to V. We know that UV and WY are corresponding and congruent segments, so we can set their expressions equal to each other and solve for x. And in doing that, we can subtract 3x from both sides and add 3, and then divide by 3 and get our solution for x, which is 7. And since we want the distance from U to V, we could plug that x value into the expression and do 6 times 7 minus 3, which gives us the value of 39. We can do a similar process with angles. Given the expressions for angles x and t, we know that x and t correspond up here in the name. So we could set those expressions equal to each other and solve.